the standard cout. And standard cout is an output stream. And what that means is, because you're working on the command line, you want to be able to push the bytes somewhere. So I have a string that I want to print, and I want to print it on the output stream of the command line of the console. So that's the first difference when you start talking about system level development versus working with a web framework. We're specifically focused on different ways to use the command line to do desktop applications, console-based applications, and even system level services or system level applications, which it doesn't matter what you call it. At the end of the day, you're talking about something that is not necessarily graphical, but is just as powerful as Amazon's website, because you've got things that have to happen behind the scenes to take orders, calculate totals, manage all of the shipping, and things of that nature. So I bring it back to, we need this IO stream because Microsoft has already defined for us a way to do output on the command line. So we need the cout. But the other thing that you notice is I said std : and this is the namespace that you would need so that the compiler knows what this type is. So immediately, if you put it in the wrong place, you get compiler errors because the compiler is trying in the background to compile this program, make an executable for you, or at least warn you up front if it's not going to work. So this is where you might look at Stack Overflow, you might look at a C++ book, and you would look at the example and at this point follow the example. But what I want to do is help you understand why that simple example is a complete C++ program, and it has a few ideas in it that make it useful for a beginner so that they can start. Because without simple examples, it's a lot harder to understand some of the more complicated things when you get further and further into the system. So Windows, Linux, Mac OS, it doesn't matter. If you're at the system level, you're going to have to get used to reading documents, looking at examples, and experimenting with putting together different bits of code in whatever language you choose. And that language for us is C++. So now that we've got this include, the next thing we need to do is we need to tell the system that we want to automatically include that standard namespace. And using this statement allows us to not have to always say standard : so that we're left with the cout. But the problem here is every program needs to have a beginning function that's known as an entry point. So when I say int main, there are a few different forms of this function by convention. And the compiler expects you to give it this function called main. And that's not random. It's a specification for C and C++ that you have an entry point, and that entry point is called main. And if you're familiar with any other language, it's the same thing. You end up with main spelled differently in some cases. Or if you need to call it something else, then usually the programming language will tell you what it needs to be called. But in this case, we're going to say main, and I put argc and argv also by convention, because when you have a command line program, you might be used to, for instance, we did dir. dir is a command line program, and in this case, it didn't take any arguments. But you can give it arguments, and when you do that, it behaves differently, right? So the same idea applies when you're working, defining your own entry point. excuse me. So you say main, and then you say argc, which means when the program is called and this entry point is reached, the system creates enough initialization in the binary that allows the program to know how many arguments you passed it and what those arguments are. So these two parameters, which is what you would call, so if I define some function, that function usually has a return type, a function name, and then inside the parentheses, it will have, param type, and then param name. And you will do this for however many arguments you need. So in this case, I only have one argument. But if I needed more arguments, then I would just continue this pattern after the after the comma, over for as many times as I need to. But for the main entry point, we only need to pass in this argc and argv. And you can call these anything you want, but again, there's a certain convention that everybody understands where you would say int main, meaning I'm going to return an integer, and that's what I'm doing here, is I'm returning an integer. But then when the program is run, the main entry point already has the number of arguments that you passed, and then the actual strings, the string-based variables or names that were provided when you call that function. And from here, you would do whatever you're going to do. And we'll keep coming back to this, so you don't have to remember it all right now. But once we're in main, then because we've included IOStream, and we've also added the using namespace statement for standard, then we can simply say cout. And notice that cout, like we were saying, it's a O stream called cout. And you've also got a I stream called cin. And an airstream. It might be another out stream called cair. I forget the definition, but we can always look that up. The point, though, is you can now say cout and the string, and then endl. And the reason you can do endl is because, again, endl is also defined, but notice that it's got the standard colon, and using the reason that you would include the using namespace statement is to keep from having to say the same thing a lot of times, because you'd have to say standard colon here, and you'd have to say standard colon here, and anywhere else where you're going to use the definitions for cout and endl that have already been defined somewhere else. But I say all that to say that is why you have to do the things that we just did just to get this simple program to work. And it's because you need an entry point that's known by the system, known by the compiler and by the linker. So the process of creating this executable is a two-step process. Well, actually three, if you count what's known as preprocessing. And that is kind of shown when you look at the properties for the project or the solution, because you've got the C++ compiler, you've got the linker, and let me see, do they say anything about the preprocessor? Yeah, they do, and they mention it in the actual C++ section. Now the preprocessor is the one, when you do an include, it's the one that looks at what's actually defined in that include. So we looked at that first level, but really the preprocessor is going to go through every include in every header file and take all of the definitions that it knows about and then apply them to our simple example so that we're able to, at the end of the day, print this string to the output stream and use all of the definitions that are either built into the language or included in the header files that either Microsoft or us or someone else has written. So for now, we'll stop right here because this will at least help you build your first program. And what we need to do from here, of course, is learn a bit more about the different types of the language, because learning about the smaller pieces, like what are the ints, what are the char stars, these things are what you would use to build, more detailed objects that you can use in functions. So if you think about something like a video game, or like how Google's search engine works, I mean, all of those things might seem complicated, but they're really built on simpler expressions. So for right now, we're returning an integer. But if we wanted to, and we will be able to do something like this in the future, we can define our own person object, and then maybe have a function that says add person that takes maybe something like the first name, if I can spell it correctly. So the first name, the last name, etc. And then returns a person. So whatever the logic is, we would be able to create a person. So this would be useful for, if you really needed a system that would keep up with people, or if you were making a video game or something to that effect, in C++, of course, because there's certain ways to do this kind of logic in every language, and the form right now is specific to C++, but these ideas will carry over to a lot of different languages because most of them have similar characteristics. Well, hopefully you found this particular video useful. Don't forget, if you like it enough, to subscribe, because there will be more videos in the future. And we're going to start from basically the ground floor, try not to be too complicated, and just continue to add to our toolbox so that we can all figure out how to just improve our skill set together. Thanks for tuning in, and we'll see you next time.